Hello guys and welcome back to another episode of this series. We are still trying to write our kernel from scratch. Last time we had a bit of hard time dealing with interrupts and interrupt stack management, but we overcame that and came out stronger. So today we are going to keep going on this interrupt handling theme here, but today's video is supposed to be short and sweet. So let's get right into this. Now, actually, before we get started, I have been working off video on some changes to the architecture-specific code. So what I did is I've reworked the CPU identification and validation code that we had before. So this is cpu.zeg, and the main thing is that I basically put everything in here into Arch-specific code. Is getting resolved through this import here, and the interface currently just has, at least the public interface, just has this has feature here that basically lets the kernel check for features the CPU can access or can handle. I was also thinking about adding a pub function validate CPU here, just so that we can choose what kinds of CPU we want to handle, and if we don't find them, just return a nice error message instead of just crashing and burning. So this is the public API, and of course if we go to somewhere here, so I went through the Intel documentation and basically pulled out all, not all, but the features I thought most interesting. So here we have them in this feature enum. And then the way this works is that I'm using some very niche things here, an enum map, as well as an I think an enum set somewhere down there. But the idea here is to map for every register output from CPU ID, the CPU ID instruction, for every leaf basically. So this one is leaf 01 register ECX. And I'm mapping every bit of that to the feature it indicates. And then I'm going to go down here. So I have this match features function here that basically goes through the match tables for a given register, and basically just sets this flags field here, which is this one, an enum set of the huge feature enum that we have before. So this basically lets us just in CPU fill CPU info go ahead and do something like this. Check if we have the leaf that we want. So basically leaf 1. Check that EX is over 0, so we have at least 1, and then we match the features of the registers that interest us for that leaf. We do the same for leaf 7 and some other extended leaves here. Right, so that means that we can go ahead and go to our main and go somewhere over here and do something like log info CPU has feature, let's call it, let's do something like this. And let's go for SSE 4.1, for example. And we can go here and do CPU.hasFeature, and I think we have SSE 4.1 here. Right. So this should just work. Let's see if we do this. And then I'm gonna prepare sure. Let's see here. And do we have... Oh, we don't. So false. Cool. Very nice. So I think we can do the same for any... let's go for SSE2 because I think I know this CPU that we've chosen has, in fact, SSE2. So let's just check that. And this should be true. And it is. Cool. Very nice. Now, going back to our topic, let's go to interrupt. And here, this is where we've left off, basically. Dispatching interrupts. So here I want to replace these lines with real dispatching code. So just thinking about how this should go. I'm thinking that this gen vector ISR, as well as all of these, should probably go into some module somewhere. Maybe in interrupt. Let's call this common.sig. Sure. And let's get these. Probably not the dispatch. Yeah, we'll leave the dispatch in there. Let's go down here. And of course, we are going to need to also bring over... hold on, let me just do this. So we are going to need this, I think. Yeah. So that should work. That should just work. Yep. Okay. Very nice. So now that we are here, we should also basically bring back that common. So let's call this. How do we go about this? Yeah, let's just import. No, I don't want to do that. Maybe common is not really the way it should be called. Yeah, actually this is not common in the sense. This is more like Arch-specific stuff. Right, so this needs to be moved to the Arch-specific code. But for now, let me just rename this to x64. If I can do that, yeah, sure. Just so that I remember. So let's do this is at import interrupt x64 .zig. Of course, we can do that correctly. And here we can just probably do x64.genvectors. Right. So this one does not need the exporting anymore. But here we are going to start running into... well, we are going to start thinking about what we want to do. So let's just write it down, right? So here's what I want to do. I want to have a sort of interface, interrupt handler, right? I want to register one or more interrupt handlers, and on an interrupt event, I want to call the handlers one by one, probably have some sort of mechanic to stop the propagation of that event. So basically, if we find a sort of terminal handler, we just ignore the ones that are lower down the chain. Not sure if this is really something we need, but I thought it would be nice to have, but I'll mark it as optional for now. And then we are going to also have default handlers in place, just in case. We have no handlers registered for that interrupt, basically. Since we have, other than the CPU interrupts, we also have user-defined ones. So these are the ones we are going to allocate to things like devices and other stuff. And we would like to, for example, if we have no handler in place, to catch that interrupt and print some sort of generic message that details the interrupt so that we can handle it. Right, so let's do this. So first of all, interface, so const interrupt handler. Not sure if this is a good name or, but we'll see. Right, so this one here will have, so let's do a basic, the basic SIG interface thing. So context, right? This one would be an any opaque. Then we'll have some handler, right? Should be a const. Let me just define this here. Let's call this handler fn is a pointer to const fn that takes in a so an any opaque, right? And it takes in a context right, and then I guess this would need to be let's call it self, and want to call it context twice. And this one would probably return something like Boolean. So we can use that as a way, just a mechanism to know that we should stop the propagation. Sure, so this one would be handler function. I'm not sure about this, but we'll try a few things. Right. So now this is the handler function. So now we need to create a basically, So we know that we have max vectors interrupts. So what we need to do is create a, let's call it handlers. And this would be a, we need our lists. So doubly linked list. Not sure where this is going to come from, but list.sig. Let's see. Doubly linked list, and we need to define our own type by giving the type, previous field, next field. Okay, cool. Right, so handlers. We also need to basically put on this handler here a next type. So I guess we don't need doubly linked lists, we just need a singly linked list. Sure. So next pointer here would be a pointer to this. Am I right? I think I'm right. So this one here would be, let's first define a const interrupt handler list is a singly linked list of interrupt handler, and next field is next. It's been a while. Is this how we use this? Yeah, field enum. This should be okay. And so here, this one here would be interrupt handler list, or rather an array of this arc specific, I think, constants and max interrupt vectors. Yes, this looks good. So this one here would be, yeah, we can do something like, so interrupt handler list, and we can do something like this, and we can do arc constants, max interrupt vectors, sure. Right, so what is the problem? Of course, it's a field definition, so let's get that in there. Nice. Cool. Do we actually want this to be a field? Yeah, no, I think we don't want that. Just create this as a variable, and we're good to go, I think. Right, so here what we are going to do is, from the context, we get the const, let's call it vector is context.vector, cool. Then we get as a constant the handler list. Not sure how we should call this. Handlers is not really a good term for this. Sure, handlers list. So handler list is handlers. What am I doing? Handler list is handlers list. Again, this needs to be reworked. At least the naming is something that needs to be looked at. So if so hold on, let's check how do we want this to go. Right, so now that I think about this, there are two ways we'd like this to go. So first of all, let's start by doing the iterator is handler list.iter, I think. Hold on a minute. Is that how we define that iter? Does it have an iter? Did we not define it? Nice. Very nice. Sure. Let's just copy this, bring that to here, and that should do the trick, I think. Yeah. Sounds okay. So let's just also bring this up here just so that we can have them all together. Right, so where were we? We were here. Does this iter work now? We don't know. Okay, cool. So while iter.next, right, we get that as handler. Come on. And we should go ahead and do this. And since we have a Boolean that indicates that we should stop, so if let's see here. So handler dot no handler. Actually, never mind. So this one would be handler of handler.context and context, right? And if we have that, we just basically bail out. Otherwise, we keep going, and if we haven't had a terminal handler, we basically call the so let's call this default handler for context, and of course we need to define those. So default handler for context of type context returns void, no error, and we should probably just do we have a log in this? Yes, we do. Cool. So log dot error, and here we are just going to go and do something like this. That's right, and unexpected. No, let's call it an interrupt has not been handled correctly. Right. And then we are going to go ahead and do something like exception, and we do something like this. And then we leave an empty line, and then we can go ahead and print out the registers, I think. Actually, before this, here I want S is in the name of the exception, and I also would like to print X, which would be its vector. So let's just do something like this. Am I forgetting something? I don't think so, no. So let's actually do, yeah, sure, let's get context, let's get registers in here. Oh, we also need context, I think. So context, what do they call that? Where does context come from? Types, interrupt types. Right, so interrupt types, and that, let's get that here. Cool. So we want the error code. So error code is sure, and then we want the RIP, and then we want I guess the registers. So let's go RX. Should probably go back and do some cleaning on this, but actually let me just try to do something. I'm just going to do this. I'm just going to go ahead and so hold on, what was this? Something like this, and then we move them to 47. Cool. And then here we can go ahead and do something like norm. So go to the start of that, then we go yeah, let's do this, and then we basically remove the rest, and then we go back there and insert, yeah, just do this to be sure, add these space, and oh no, okay, cool. So I need Control V, escape that, go to yeah, we need to go to the end of that, or rather let's just do an append here and do So this space X like this, and then that should be all we need. Right, very nice. So just need to do the same here. Cool. Did I lose that? Yeah. Okay, sure. Probably save this as a. So we want to go here. We want to do this. We want to go here. And we do something like this. And we go down and we stop it. And here we can go ahead and do something like this. Oops, forgot one. Cool. So we can get rid of this. We can go do this. Go uppercase. Nice. This maybe took more time than it would have taken us to do it by hand, but who cares? So we want flags. I guess flags should come just here. So flags. Flags. Hold on, I can type this. Right, and here we'd like to have the CS. Sure. Now, how we go about this? So, interrupts. We are going to need a function that takes a vector and returns a string. So, vector to name. Sure, let's call it that. And this would take context.vector. Here we have vector just as a standalone. And then we'll have context dot error code. Yes. And then context dot RIP. Context dot flags. Sure. Context dot registers dot and I think here we could actually do something smart again. So let me just do this. I want to go here. I want to go to the end of this. Yeah, probably not what we wanted to do, but let's try this again. Let's copy these. Let's take all these, replace them. Right, so let's re-record this. We want to go to the start. We want to, let's say we want to delete 3 of those. And then we want to go here, and then we want to delete to the end. And then we want to go back to the start and do context dot registers dot and then we word, and we go lowercase inner word, and then we append to that a thing there, and that should do the trick. So let's do that 15 more times, and that's pretty much it. So here we need CS, so context.cs is the very last one. Cool. So now we need function vector to name takes in a vector, which would be a U64, I think, and returns a slice of const u weights. And this one is just one big switch statement, I think. Maybe we can do something like this. Maybe we can do something like this. Right, so here I'm going to pull this out. Right, so we have yeah, let's just do them, I guess. So let's do 0, and we have 21 of those, so let's do 20 more. And let's do this and go sure. So I think we have 22 of those then. Yeah, sure. Let's just do this. Cool. And this one goes here, and this one becomes, I think it's divide error dash de. Okay. Yeah, they would want us to rename this, right? So to name. Okay. Very nice. And we forgot that this needs to become to be coming from context. Very cool. Right. So here is how this is supposed to be. If we run this, whoops. Let me just get rid of this and this. Right. So if we run this as it is, currently we are hoping to see this kind of format pop out the other side. So let's do that. Let's first see what we've broken, because obviously unable to load types.seg file not found. Right, I see where the issue is. I think it's in here, since this does not exist anymore. And what else? It's not marked as public. Fair. Let's see here. Again. So what is the problem here? Undefined symbol dispatch interrupt. Oh. Okay. So I guess we needed that to be still to be exported still. Export. Very nice. So what now? Singly linked list. Type is not a function. Type is not a function. Oh, of course. Singly linked list. Okay. The error is weird, but it's fair. Switch must handle all possibilities. What do you mean? Oh, I see. Okay, I see. I guess we just need to add an else here and do sure, unreachable. Not that kind of language, okay. Unreachable this way. Right, so let's run this. We are hoping to see our nice exception. Okay, hold on 1 second. Oh wow, I think we've broken something. I'm not an expert, but I think we've broken something. Right, so UD invalid opcode somewhere, but at some point we should have had our page fault exception. Let's try searching upwards for true. No, we've overrun our we have overrun our history limit. So let's try to do this again and be very quick on. Okay, so I've tried to interrupt it fairly quickly this time. Let's search up for true, and okay, so this time we get it. So an interrupt has not been handled correctly. Cool. RIP is this, and the exception is UD invalid opcode. Of course, and so I guess we should probably in our default handler here at the end. Just probably die for a bit, or for so volatile. Let's just halt here. Yeah, because we basically want all our exceptions to be handled, so there's no reason why some of them should not be. Okay, so let's see here. Invite opcode again this time. And it looks like it's the same REP. So let's just do so opstamp, or rather LVM opstamp should just accept this. Sure. So kernel dump.txt. Sure. And then if we try to find this, so sure, go ahead. Why doesn't it find that? So let's go FC 018 95A. Okay. What is this? UD2 descriptors.init. Oh, do we have a panic somewhere in main? Kernel main. Oh, okay. Very nice. Very nice. Okay, so I should probably just remove that then. But I think I've put it there to test our exception handling, so that should be okay. Except that, yeah, I'd have liked to leave the panics to be handled by the panic handler, Zig panic handler. And I think we could have defined a custom panic handler somewhere here. Is there like panic handler instead options or something? Isn't that something that we can define? Panic. I think it was something like that. So if I go to Zig panic handler. Panic. No. Panic handler. Yeah, so const panic. Okay, so this is what we should probably do. But does this work only for debug? Okay, nice. Very nice. We'll see about this in a while. Right, so for now, I'm just going to address the immediate problem I see, is that, and that is that this looks like kind of crap. So let's add a line feed here. Let's add a second one here. Whoops, and do something like sure. Let's add a few just to balance them out. Sure. And then we can probably just do something like this. Bring this here and add another line feed down here. For these ones, I think all of these, except maybe flags. So let me just put flags up here. So for these ones, except maybe code segment, So let me check what the code segment looks like. It's 8. It's a hex value. That's fine. So for the rest of these, I would like to do something like this becomes 0x, something like, no, the other side, 16. Yeah, sure, something like this. And then we can go here and do 0x just so we know it's a hex value. And we can do that here too. Let's just, oops, not really what I want to do, but okay. Okay, let's see here. Okay, oh yeah, of course, we removed the exception that triggered this. Let's bring this back. Okay, nice. That looks like something. I think I forgot something important. Interrupt. Yeah, so let's do this and let's substitute this by 0, that. I want this to be padded with zeros, not just spaces. And I also would like these to have the same width here. Cool. This is just for visual flair, but you know what? We live for the visual flair. Very nice. That's a bit more readable. And yeah, so maybe flags does not need. Oh, I see. I see what the problem is. So this one is RIP and this one is flags. Right. I would explain things. Very nice. Error code is 2. We have page faulted. Whoops. Sure. Very nice. Probably do something like exception. Something like this, and just remove that from there. There we go. Very nice. Now, just add a to-do here, because this is supposed to be... again, this is not supposed to be platform specific, so the actual registers here should have been formatted by architecture specific code. So basically we should just ask it for give us a registers format, or rather formatted registers, and it should do that for us. So I think I'll do this some time later off recording. But yeah, for now we are happy with what we have. So let's try to actually register one of the handlers here, just to see what this would look like. Right, so I think I'm just going to go to main, because so kernel main, and just after we finish with this, yeah, I don't really want to import interrupt here, so let me just go here, interrupt init, and then we do interrupt dot. Oh, wait, hold on a minute. I haven't exposed any function to actually register stuff. So public function, register handler, and this would take, let's think about this, an interrupt handler of type interrupt. Yeah, okay. Handler, there we go. This one returns void, maybe errors, who knows? We'll see. Oh, and of course we need to know for what vector this guy wants to handle the interrupt. So we have the vector. We'll get the handler list is handlers list of that vector. Sure. And then here we have handle list.append, and we should try to append interrupt handler to that. This one, does it error out? Not sure. Oh, interrupt handler, like so. What do you mean? Handler, of course. Right, so this one here would do the trick, I think, and we just return from there. Yeah, sounds okay. Sounds pretty okay, actually. So interrupt dot register handler for vector xe. Sure. Again, let's mark a to do as part of Arch-specific code. Maybe have an interrupt exception vectors enum. Sure. Just to make this a bit easier to work with. Right, so here we want context is I would like to see. Let's actually create const interrupt handler. Let's call it demo interrupt handler is a struct, and this struct here has a public function that I'll call interrupt handler. Sure, that returns an interrupt handler. And of course this takes a self, which would be a pointer to this. Right. And this here returns so context is self. And then handler is let's call it handle interrupt. Yeah, of course. And of course we need interrupt handler here to be in interrupt dot interrupt handler. Does that track? It does. Cool. So we just need to create a function handle interrupt that basically takes in a context as a pointer to any opaque, and a context which is a pointer to interrupt dot interrupt types. Sure, this is kind of bad. Let's say Boolean. This is kind of bad, but well, it's for demonstration purposes, so we are going to go with it. So import interrupt types.seg. Come on, .seg. Okay, does that work? It does. So first of all, return true. We want this to break here. And here we are just going to do log dot info demo interrupt handler called something like this. Right, so here we are going to basically get rid of all of this, and we are going to do const. Let's think about this. So this is something we want to create probably here. So const handler demo handler is demo interrupt handler, something like this. Right, so this one would be demo handler dot interrupt handler. Yeah, should probably get a few of these errors. Not marked as public. Of course, it's not. So I think this is the one we're talking about. Is there anything else we need to mark as public here? I don't think so. Cast discards const qualifier. Expect type pointer to demo interrupt handler, but found a pointer to const. Okay. Let's see about that. Let's see. What is going on here? Unused function parameter. Of course. So let's just do context. With context any and context. Sure, something like this. Context and context. And this goes away. Right, let's see here. Invalid string S4U64. What? Oh, of course. Wait, hold on a minute. I'm missing something here. So this field next should be it's an optional field, isn't it? So everywhere else we've used this list. Let's go to memory. Let's go to bmem, I think. And here, if we go to list item, yeah. So there are optional things of thing. So yeah, I can just do this, and that should solve the problem. Almost. So invalid thingy for thingy, but expected 2 arguments. Okay, that's fine. Let's fix that first. Where were we? I forget. Descriptors. Yeah. So we were about here. Let's see. Is this just the format thing here? No field or member function named append in list. What? Am I missing something? This creates a list. Wait, what? Did we not implement append? What are we doing here? What are we even doing here? Oh, because append is too expensive. We need to go through the list. Okay, that's fine. That's fine. That is actually fine. So let me just go here and do prepend. Okay, we're getting there. So what is the problem here? Parameter declared here, expect type pointer, but found no pointer. Okay, very nice. So this one here needs to be a pointer then. And that means that in descriptors, this needs to become I guess we should do something like this. Discard qualifier. Again, why? Oh, because yeah, right. All right, hold on. This one returns a pointer, and this one returns a pointer to that. Okay. So now, expected type, but found a const. What is going on here? Okay. So for interrupt handler is demo handler dot interrupt handler, and this one becomes interrupt handler. How about that? Right. Okay. So now we just have this annoying error here. Invalid format string S4 type U64. Okay, this one is very annoying actually. Let me just go ahead and go to my make file here and add so trace reference, and let's do something like 20. Wait, what's going on? Oh, is it? Oh, okay, it's reference trace. Add f reference trace 20. All right, let's see. Is it not reference trace? What is going on? Okay, let's just rebuild this and see. It should tell us what we need to put in there. Oh, it's reference trace, but equals. Very nice. Okay, let's see. There we go. So it's in our default handler, line 41. So let's go to interrupt. No, not this one. Interrupt this one. Line 41. So, oh, of course, we flipped these. Yeah, okay, my bad. So context dot vector, vector, and this one just goes. Oh, right. Sad life. Let's go. Okay, that's not good. That's not good at all. Let's do something like log.info colon how do we go about this? Log.info handlers list has, and let's do something like this and do handler list. Handler list. Okay, head is null. How come? It's the correct vector. It's 0xe, and that is the vector that we've registered here. Is this called before or after? Log.info registering demo handler. Sure. Yeah, so here we should have it. Right, let me do something else here. Handle list. Yeah. Maybe our list is just wrong. No, it's not. Oh, wow. What is this? Okay, is there some problem here? Page fault is 14. It's fine. So how come this list has not been... am I missing something here? Okay, so that was the problem. Yeah, we just basically copied the list head when we just did this. So we actually need to take it by pointer so that we can prepend to the actual item in our array here. Okay, that was it. So, but the problem here is that we have a problem. So I'm going to need to take a look at this. But, oh, I think I see what the issue is. The issue is that my interrupt handler here returns true. So I think if I return false, I should see it getting called, and then I should see the default handler just print the exception and hang, instead of just looping on the exception. Yeah, cool. Very nice. So demo interrupt handler called with context, all the nice things, and then we have our exception handler here, the default one doing its thing. Cool. So now I probably would like to register a or rather put in place a default handler for page faults that basically gives us the I guess address where the page fault occurred, and we all know that that address is put into CR2. Do we have that info somewhere here? I think we should find it. No, we don't have it. But if we go to there we go. So it should be over here, and we should look for 14. Yes. So a lot of very interesting things we don't care about, and at some point here they should be telling us that there we go. The address that generated the exception, page fault, is loaded to CR2. So basically what that custom handler here would do is it would print CR2 right after the flags. Actually, let's should probably just put that on the same handler, shouldn't we? Just so we can see it. Let's do something like CR2 0x0 16 15 16, and here we can go ahead and so just after flags. But here we need to read CR2, so I guess we need to do some assembly voodoo magic. Volatile tile. And I guess we could read to move CR2. How does it go again? So this is the source, and then we need to put a destination here. Ret, so outputs is ret, and I guess we just return that as a U64. Not sure if this works, but so it is looking for a string literal. Let's give it this one. Actually, let me just zoom into here. Yeah, I'm not sure if this is going to work, but you know what? Let's go ahead and test this. Yeah, of course it's not going to work. So what were our constraints? I think we could just do something like this, can't we? Fine. Let me go to IO. Sure. Okay. So if we do something like this. It should at least give us something, shouldn't it? Let's see. Oh, there we go. That actually worked. I'm surprised. Right, and this address here should be the address that we've tried to read from. So C53400. C53400. Cool. Very nice. Well, that's pretty much it for this one. We still have a few things to iron out on the exception handling side of things, but I'm going to consider that this chapter here is done. As always, if you've liked this type of content, please hit like, subscribe if you're not already subscribed, and if you have questions, remarks, or you just want to say hi, please leave them down below. Until next time, I'll see ya. Fuck it out.